First of all, let's emphasize some of the keywords of the title. We are trying to develop this event-driven, agent-based approach to support the operational maintenance of buildings. So we are focusing on that particular phase. First of all, some ingredients of the reasons, the motivation why we're doing that. That are also sometimes enabling methodologies or technologies for what we're doing. Also, I guess that all of you are aware of the International Standard Series 19650. What is important from our point of view is that the project information model, not the BIM model, that is delivered during the design phase is then enriched, updated, changed, and converted into an asset information model throughout the construction phase until the end over the building. And it is the place where the structure information, where we store most of what is needed for the operation phase of the building. Besides that, there is a lot of research regarding cyber-physical systems that are defined as those systems that are made of cyber-physical components. So the AIM will be part of the cyber part of the cyber-physical system, made of communication and networking of distributed systems, most of them also hosting edge computing. There you can find one of the references. I've cited this paper because it is about industrial buildings, and they emphasize how cyber-physical systems are the right framework to develop a digital twin for the management of not only the building, but the building and production at the same time. So they advocate that this is the right approach to realize management systems in a modular, flexible, adaptable way that is what is needed in order to be competitive in our society. And another ingredient is legislation. The EU directive on public procurement that was incorporated in many of the EU member states' legislation in Europe, they in 2014 encouraged the application of these electronic means for design and management in order to improve efficiency and transparency of construction processes when it comes to public works. What they've done in Italy is that from the 1st of January this year, it is required that we use this system in order to manage the construction process. So in other words, AIM is required right now, okay, in most of the member states. If it is required, we can rely on that kind of information in order to develop our system. And, okay, state of the art in this field confirms what we have done. So there is a big effort in the development of collaborative platforms of cyber-physical systems, in the sense that they are a combination of hardware, software, edge computing, communication modules. And one very important thing is that what is required is that what we do is adaptable or portable. We can, if we develop a system that must be suitable for several scenarios, several buildings, several types of and requirements in terms of management. And so the cyber-physical system now is also involving another unit that is people, because people are a big part and a very important part of the management. So our suggestion is, why don't we use this architecture? It is made of a communication backbone, and we technically will see it. We realized we have produced a bus communication system made of the bottom layer data tracking and data collection from the physical part that can be done using a variety of protocols, and then this middleware for inference, for data analytics, for storage of structured and unstructured information, and the top layer, of course, that is strongly related to the use and type of management they want to do, so dashboards and other management systems that are related with the building. Okay, technically, we figure out this cyber-physical system that is made of agents. One agent might be the building, any building monitoring system that is providing data to the bus, and another component will be the Bayesian network activator. We have called it in that way because we figure out that given we are dealing with the environmental monitoring and operation maintenance, so environmental monitoring is one of the most important topics. There will be one space agent per each room in order to check what the condition is and to infer whether some failures occurred. And the space agent will exploit an inference engine that we have developed in the form of Bayesian network as they are really suitable for that. Besides that, a diagnostic agent that gets inferences and locate the subsystem of the building that may have caused the problem if a failure occurred. The bus is basically, we have, implemented the bus in the form of an MQTT broker, and it works in this way. Every agent can subscribe to a topic, and it means that when a record comes for that topic, the broker will be in charge of delivering that message to the agent that subscribed. In this case, we have a new data, new evidence from one room, and the topic identifies the room and the number of sensors. If a space agent, the space agent managing the Bayesian network for that room, has subscribed to that topic, the broker will deliver the message to the agent. That means the agent is activated just in case a new evidence is available. That's one event driven. And it is an agent-based approach because of the overall functioning, the way it works is based on this interaction between agents. The string to define topic can be the one, so of course the building sensor, the number of room, number of sensor, and there is an example at the very bottom of the slide. And then here is one example of Bayesian network. Of course, we said the approach must be portable, it must be flexible. So we cannot think of developing one Bayesian network per each room of each building that is under management. So our idea is, let's exploit the object-oriented Bayesian network tool that is a network having a lot of instance nodes, and every time a new, the Bayesian activator must generate a new space agent, the network associated to that agent is an instantiation of this OOBN. So every instance node is instanced with the number of the room and the number of sensors that is supposed to manage. And it comes from the payload of the message sent by the BMS agent. At this point, as we will see in the proof of concept, the space agent is in charge of getting the evidence, setting the evidence in the network, and triggering the inferences in order to read the result and notify, just in case there is high likelihood that any failure occurred. Last thing is diagnostic agent. It exploits queries. So what it does is, okay, if just in case any failure is notified, it gets data from the payload of the messages, and it performs a query in order to locate the most likely, the subsystem that is very likely to be involved, to have been involved in the failure. This is the final workflow. Okay, our proof of concept was developed for a middle-sized hospital that is currently undergoing refurbishment. So they have done a project. They have a federation of models, in this case IFC models, the architecture, the air conditioning, technical furniture. And what we are figuring out is, as soon as they start sensor, the gateway will be programmed in order to add in the payload the string of the topic, along with the number of room and number of sensor. And this data will be delivered to the MQTT broker. That is the flow at the bottom right of the slide. You see the flow that was developed in Node-RED. Node-RED is this IoT environment for prototyping IoT devices. You see the three nodes getting data from sensors, the set topic, so adding the topic property to the payload, and then publishing to the bus the final results. Second floor is this one. At the very left of the floor, we have the node that is reading from the bus, and then connecting with the REST API to a web service where the Bayesian network is available. Okay, they upload the domain, they set the evidence, they get the result of the evidence, and then they build the message from this JSON object. As you can see from the second scenario, there is high likelihood that the fan bearings are aged, and so that's the subsystem that might have been involved in a failure in this case. And so the final flow is about diagnostic agent. The diagnostic is notified by the broker that a failure occurred. It works out a query that is a form of standardized query, and we used some property of the IFC model in order to select that subsystem that has been involved in the failure. As a result, we have put together the procedure that is now required to build some sort of AIM. First, object-oriented Bayesian networks that can be instantiated one per each room. And then we did inference using this approach, this bus communication backbone, in order to advise maintenance teams that a failure occurred and what is the subsystem of the building that was more likely to be involved in that failure. What we think is that we encourage people to do research in this field, and we will also move forward with that, because we think that this combination of agents can be used to do systems that are competitive, that are portable, flexible, adaptable to various types of buildings, and can help us do a good management of building the operation phase. Okay, thank you. Thank you so much.